Design a compression helical spring to carry a load of 600 newtons with a deflection of 28 mm. The spring index may be taken as 9. Assume the following values of spring material. Permissible shear stress is equals to 350 MPa. MPa means megapascal. And modulus of rigidity or shear modulus is equal to 84 kilonewton per mm square. And Wahl's factor is equal to 4c minus 1 by 4c minus 4 plus 0.615 by c, where c is spring index. So here we have to design a compression helical spring. So we are going to design compression helical spring. So we have to design compression helical spring. Here compression helical spring to carry a load of 600 Newton. So here helical spring is subjected to a load of 600 Newton. So load, axial load. So first of all, note on the given data, load W is equal to 600 Newton, given load, and deflection given. So deflection denoted by delta. Deflection is equal to 28 mm, and spring index, given spring index. So spring index is denoted by capital C. Spring index capital C is equal to how much? 9. Spring index is equals to 9. And also given modulus of rigidity. So modulus of rigidity. So modulus of rigidity, G is equal to how much given? 84 kilonewton per mm square. 84 newtons per mm square. We also given permissible shear stress. Permissible shear stress. So permissible shear stress denoted by tau. So tau is equal to given how much? 350 MPa. 350 megapascal. MPa for megapascal. So tau is equal to megapascal means Newton per mm square. 350 Newton per 1 megapascal means Newton per mm square. Okay, tau is equal to 350 Newton per mm square. And also given Wahl's factor. So Wahl's factor is equal to, so Wahl's factor denoted by Kw is equal to 4c minus 1 by 4c minus 4 plus 0.615 by c. So this is Wahl's factor. Okay. So using this data, we have to design a compression helical spring. So design of compression helical spring means we have to find 4 parameters. First parameter is mean diameter of the spring coil, and the second parameter is number of active tones of the coil, number of active tones denoted by small m, and mean diameter denoted by capital D. Next we have to find free length of the spring, and also at last we have to find pitch of the spring coil. So we have to find 4 parameters. Free length of the coil means LF, and pitch of the coil small p. So we have to find these 4 parameters for the given data. Stone. Mean diameter of the coil. Let us find mean diameter of the coil. Spring coil. So capital D. So first we have to find mean diameter of the spring coil. So let D is equal to mean diameter. Let D is equal to mean diameter of the spring coil. Next, small d is equal to diameter of the spring wire. Small d is equal to diameter of the spring wire. Diameter of the spring wire in mm. So this is mean, capital D is equal to, let us consider capital D is equal to mean diameter of spring coil in mm. Okay now? So how to find mean diameter of this spring coil? So mean diameter ela find out cheyali. So using maximum shear stress induced in the spring wire. So we know that maximum shear stress, tau maximum shear stress induced in the spring wire is given by so what is the formula? Tau maximum shear stress or permissible shear stress, maximum shear stress or permissible shear stress is equal to 8W C by pi d square. So we have to multiply with one constant. We have two constants, Ks and Kw. Ks and or Kw. Okay na? So this is stress factor and this is Wahl stress factor. So whether we select Ks or Kw, it's depending upon question. So we should know whether we consider curvature effect or not. So curvature effect considered cheyala leda. So if we neglect curvature effect, we select Ks, we take Ks. Okay. If we consider curvature effect, we have to write Kw here. So how do we know? So based on the given question, in this question he clearly given Wahl's factor. Here Kw means Wahl stress factor. So he already given Wahl stress factor. So we should consider curvature effect. So here we should mention considering curvature effect. Or effect of curvature. So tau maximum, shear stress tau maximum is equals to Kw into 8Wc by pi d square. Using this formula we can find small d. First of all we can find small d. From small d finally we can find mean diameter of the spring coil. So what is the relationship between small d and capital D? Here capital D means mean diameter of the spring coil and small d means diameter of the spring wire. So what is the relationship between capital D and small d? So we know that spring index capital C is equal to capital D by small d. Spring index capital C is equal to capital D by small d. So spring index is a ratio of mean diameter of the spring coil, okay na, to the diameter of the spring wire. So mean diameter of the spring coil by mean diameter of the spring wire. So here what is the value of capital C? Capital C already given in the question, how much? 9. Capital C is equal to 9. First of all let us find small d. Okay na? Then transpose D, capital D is equal to what? Capital D is equal to mean diameter. D is equal to, division becomes multiplication. You will get 9 into small d. So first we need small d. We have to find diameter of the spring wire. Using this formula we can find d value. So here W means axial load. Okay na? Next spring index. Kw means Wahl stress factor. And tau maximum means permissible shear stress. Permissible shear stress is already given 350 megapascals or 350 Newton per mm square. So here first we need Kw, Wahl stress factor. So Kw is equal to, we given already formula. What is the formula? 4c minus 1 by 4c minus 4 plus 0.001 615 by C. So C value how much? C is equal to 9. Put C is equal to 9 here, you will get Kw. Okay, let us find Kw first. So Wahl stress factor Kw is equal to, so formula 4C minus 1 by 4C minus 4 plus 0.615 by capital C. So Kw is equal to, so here C is equal to how much? Capital C is equal to 9, spring index given 9. So 4 into 9 minus 1 by 4 into 9 minus 4 plus 0.615 by 9. So Kw is equal to 4 9s are 36. 36 minus 1 35 by 4 9s are 36. 36 minus 4 32 plus 0.615 by 9. So if you calculate, you will get a Wahl stress factor, Wahl shear stress factor as 1.162. This is the value of Kw. Now we know that permissible shear stress tau maximum is equal to Kw into, with considering curvature effect, Kw into 8W C by 5D square. So tau maximum how much? 350 Newton per mm square is equal to Kw 1.162 into 8 into how much load given 600 newtons into C 9 whole divided by pi d square. We need d value. Okay, transpose d square to left hand side and 350 to right hand side, then you will get d square is equal to, so transpose multiply, here we can write 1 into 350. Now transpose 350, multiplication becomes division, division becomes multiplication, 1 into d square. Now 1.162 into 8 into 600 into 9 by whole, okay, now whole divided by pi into 350. So if you calculate, and you will get d square value as, here I got d square is equal to approximately 45.66. Now apply square root on both sides. D is equal to square root of 45.66. Root over 45.66. Actually you will get approximate value 6.76 mm. Okay, 6.76 mm. So wire diameter D is equal to 6.76 mm. Now, so we have to check design data book, and we have to take standard wire diameter. So from the design data book we can take spring standard wire gauge number 2. So its diameter will be D is equal to standard wire diameter SWG2. Okay, na? SWG2. So standard wire diameter SWG2, diameter, wire diameter will be D is equal to 7.010 mm. Okay, so this value is closer to 6.76 mm. So we have to select this wire diameter. So design data book lo manam ee spring SWG2 ante standard wire diameter table untundi, aa table ni chusukoni SWG2 ఇక్కడ SWG ante standard wire gauge or spring wire gauge. Okay, so spring wire gauge 2. So anyhow, here now what is the wire diameter? 7.010 mm. Now find mean diameter of the coil. Mean diameter how much? D is equal to, what is the formula for mean diameter? D is equal to C into small d. C means spring index 9 into D means wire diameter 7.010. So therefore D is equal to, what is my mean diameter of the spring wire? So you will get 60 point, here I got 63.09. Here I got 63.09 mm. 63.09 mm. Next, even though we can find outer D naught. D naught means outer diameter of spring coil. So outer diameter D naught is equal to what? D naught is equal to mean diameter plus wire diameter. So mean diameter, here I got 63.09 plus wire diameter 7.010. So you will get D naught as, D naught is equal to, if you add if you add, you will get 70.1 mm. 70.1 mm. Therefore, outer diameter of the spring coil is 70.1 mm. 70.1 mm. So this is first parameter in the spring design, compression spring design. So mean diameter equal to 63.09 mm. Next, let us find the number of active turns in the spring coil. So next, number of turns of the spring coil. Number of turns of the spring coil. So number of turns of the spring coil denoted by small n. So small n to denote chestam. So to find a number of turns of the spring coil, we have to use deflection of the spring. Using deflection of the spring, we can find n value. So we know that deflection of the spring is given by deflection of the spring. Delta is equal to 8W C cube n by GD. 8W C cube n by GD. Okay. So where G is called shear modulus or modulus of rigidity, and W is load, and C is spring index, and N is number of turns, and D, small d is Y diameter. So delta means deflection. Here deflection is how much? Given 28 mm. So 28 is equal to 8 into load 600 newtons into C cube, spring index 9 given, 9 cube, into N is our unknown. We don't know what is the value of N. And G how much given? Actually given shear modulus or modulus of rigidity, G 84 kilonewton per mm square. Actually given kilonewton per mm square. Convert kilonewton per mm square into newton per mm square. Kilo means 10 cube. So 84 into 10 cube newton per mm square. 84 into 10 cube newton per mm square. So G is equal to 84 into 10 cube into D. So Y diameter how much? 7.010. We need N value. Now transpose the denominator, all denominator values to left hand side. Then you will get 28 into, division becomes multiplication, into 10 cube into 7.010 is equal to 8 into 4. Sorry, 8 into 6, 6 8s are 48, so 4800 into 9 cube means how much? 729 into N. Now transpose these two, then N is equal to what? Multiplication becomes division. 28 into 84 into 10 cube into 7.010 whole divided by, okay, whole divided by 4800 into 720. So if you calculate, you will get a number of turns. Okay, if you calculate, you will get approximate value 4.711. But the number of active turns cannot be a decimal number. It is always a counting number. So 4.7 means we can assume 5 turns. Say 5 turns. Okay. So number of active turns of the spring coil is 5 turns. Okay. So therefore number of active turns of the spring coil so N is equal to, we have got 5. Suppose we need total number of turns. Suppose we need total number of turns. Total number of turns denoted by N dash. So N dash is equal to, suppose let us assume Here spring is, helical spring is squared and squared. Helical spring is having squared and ground ends. Suppose helical spring is having squared and ground ends, then total number of turns n dash is equal to n plus 2. N dash is equals to n plus 2, standard formula. So n how much? 5. So 5 plus 2, 7. Therefore number of turns is equals to 5 plus 2 means 7. So number of turns is equals to 7. Next third parameter, free length of the spring. Free length. LF means free length. Free length of the spring. So LF is equal to, what is the formula for free length? LF is equals to n dash. LF is equals to n dash. I think here formula n dash d plus delta plus 0.15 delta. So now LF is equals to n dash how much? 7. 7 into wire diameter 7.010 plus delta 28 mm. Deflection. Delta means deflection. Plus 0.15 into delta 28. So if you calculate, you will get around 81.27 mm. This is free length of the spring. Free length of the spring. Next, let us calculate. At last, we need to find the pitch of the spring coil. Pitch of the spring coil. Pitch of the spring coil. Pitch of the spring coil denoted by small p. So small p is equal to formula free length by n dash minus 1. Free length by n dash minus 1. So p for pitch. So pitch is equal to 81.27. Free length 81.27 by n dash minus 1. So 7 minus 1. So 81.27 by 6. If you calculate, you will get pitch. P is equal to approximately 13.545 mm. And this is pitch of the coil. And this is free length. Free length is equal to 81.27. Pitch is equal to 13.54. And the number of turns 7 and number of active turns 5. And mean diameter of the coil. So I think we got around 63.7 something. Okay. So this is the procedure to design any compression helical spring.